All right, so I really like number 7 on section 8.2, you guys, because it hits a lot of concepts with very little math, okay? Like very little calculating, okay? So here's the deal. So in number 7, you've got this little like spring-loaded gun. So here's the spring-loaded gun. It's going to shoot a marble off the table. All right, and our goal is we want it to go a distance of d, which they tell us is 2.2 meters. Okay, so that's our goal. All right, guys, can we again pull the side conversations, please? All right, so it says that Bobby compresses the spring 1.1 centimeters, but the marble lands 27 centimeters short of the box. All right, so the idea is this. If we compress the spring a distance of 1.1 centimeters, then I'm going to use, and this is what I did when I went through this with Anthony this morning, let's call r the distance that the ball actually goes. Does that make sense? So d, this black distance d, that's our goal. All right? Now, how far the ball actually goes is up to how far we compress the spring, right? Does that follow? So let's call r the distance that it actually goes. All right? So the kids discovered that if they compress the spring 1.1 centimeter, then it falls 27 centimeters short. So that corresponds to r being 1.93. So does that make sense? Just like kind of my train of thought there? All right, so the question says, how far should they compress the spring? I don't know why they changed the name here. How far should they compress the spring to have it hit directly? So the question is, what does this need to be to make it so that r is 2.2 meters? Follow? All right, so the question basically is, what's the relationship between x, how far we compress the spring, and r, how far the ball goes from the edge of the table? Cool? Mm-hmm. Now, projectiles. Does the velocity at which the ball is launched affect the time it takes to hit the ground? No. So, what is the relationship between the velocity of the ball going off the table and how far it goes? Okay, so what effect would, say, doubling the velocity have on the range? Double, right? They're proportional. So this range is directly proportional to the velocity at which the ball comes out of the gun, right? Does that make sense? Okay, so the range is, what symbol do you guys use for proportional? Do you guys use the little fish for proportional? Good? Yep. If you've never seen that, that just means is proportional to. All right, so now we got to figure out how much we squish the spring affects the velocity that it has when it comes out, right? So where is the velocity of the ball coming from? The spring. So we're just converting elastic potential energy to kinetic energy. So that means that the elastic potential energy that we've got when the spring is squished ought to equal the kinetic energy of the ball as it goes off the edge of the table, right? In other words, 1/2 k times x squared ought to equal 1/2 m times v squared, right? Okay, well, let's see. If we simplify this, we can cancel out the k's, or cancel out the 1/2s, I mean. And let's see, let's solve for either x or m. It doesn't really matter which one. Let's solve for x, I guess. So if I solve for x, I get x squared equals m over k times v squared. Square root both sides, and you get x equals the square root of m over k times v. So what's the relationship between how far I squish the spring and the velocity of the ball as it comes out? 1-to-1. They're proportional, right? That's what this is showing us, right? Double the velocity. To double the velocity, I got to double my x, right? Make sense? Oh. So my range is proportional to the velocity, which is proportional to how far I squish the spring. So this is just a simple ratio. Right? I just want to solve this. So it's 1.1 is to x as 1.93 is to 2.2. And solve it, and you're done. Does that make sense? Yeah, Sarah?
Will the one on the final be like this?
There's a lot going on here. And I feel like I've been trying really hard to give you guys stuff that sort of doesn't use numbers, and that's what this does, you know? I mean, let me come back to that in 1 second. Is everybody okay with this? About this, Daniel?
Yeah, what's the actual answer?
1.25.
Is it like a coincidence that you can just make a ratio with the r and the x values and just solve for the other?
No, that's not at all. That was the point of this whole
Okay, yeah. Well,
thing.
okay, so you don't have to do the EP equals K thing then, right?
The reason you have to do the EPE equals KE thing is to show that the velocity at which the bullet, or the marble comes out of the gun is proportional to x.
Okay.
Does that make sense?
Yeah, okay. Cool.
All right. Good? Okay. Any other questions on this one?